Welcome back to HyperTalkPod, everyone. I'm Elias Thorne, your host, and we're diving back into the world of AI. But today we're looking at something pretty fascinating. It's something that everyone's talking about, the aha moment. Now, not for us humans, but for AI. Joining me today is Dr. Olivia Chen. She's an AI researcher who's been looking into all the amazing ways these systems learn. Olivia, welcome to the show.
Thanks for having me, Elias. It's great to be here.
Now, before we dive into all the technical details, I'd love for our listeners to get to know you a little better. What first got you interested in AI? I know you've got a great story about your time at MIT.
Oh, are you talking about the one with the ants that led to a coding epiphany on a train?
That's the one. Please tell us more.
Well, I was in the middle of my PhD. I was really struggling with natural language understanding, and I just hit a wall. Months and months of work and just dead end after dead end. Feeling pretty discouraged, I got on a train to a conference, hoping to find some inspiration. And wouldn't you know it, a paper on ant navigation caught my eye.
Ants. I'm really intrigued. How did those little creatures lead you to AI?
I was struck by how these ants, with their very limited individual intelligence, could solve these complex problems collectively using pheromones. It was like a light bulb moment. Could I apply this concept to my algorithm? The idea of the model leaving these like digital pheromone trails, allowing it to learn from its past attempts. It was just so exciting.
So, Anne sparked your own aha moment in this aha moment for AI that we're talking about today. It involves a language model called DeepSeek R1, right? Specifically, its earlier version, DeepSeek R1-0.
That's right. The team was training DeepSeek R1-0 using reinforcement learning, which is a bit different from the typical supervised learning approach.
Now, reinforcement learning, for those who haven't gone too deep into that, can be a little tricky to understand. Could you break that down for us, Olivia?
Of course. Imagine you're teaching a dog a new trick. You don't hand the dog a manual on how to roll over. You reward it when it gets closer and closer to what you want it to do. Reinforcement learning is kind of like that. You give the AI a task, and it tries different things, and it gets positive reinforcement when it starts to figure it out.
So it's less about programming every step and more about guiding the AI towards a goal through this feedback loop.
Exactly. And this is where things get really interesting with DeepSeek R1-0. The researchers saw a fascinating change in the model's behavior. At first, it seemed like it was just randomly exploring, but then it suddenly changed its approach.
And that's where the moment comes in.
You got it. Instead of trying every approach equally, it started spending more time on the challenging problems, the ones that it had struggled with before. Imagine you're trying to bake a cake, and you fail a few times. But then suddenly you realize that the oven temperature is the key. So you start focusing only on getting that right.
That's a really good analogy. It's like the model realized, hey, if I focus on these harder problems, I'll learn much faster.
Yeah.
This reminds me of when I was learning to play the guitar. I struggled for weeks, trying different techniques and getting nowhere. Then one day it clicked. I figured out how to hold the pick correctly. And all of a sudden, everything became so much easier.
It is fascinating, isn't it? It's not that the AI suddenly got more knowledge or processing power. It was more like a change in strategy. Like it realized that focusing on the tough parts was the way to learn.
So this wasn't something that was explicitly programmed into the model. It was more like an emergent behavior, a result of the learning process itself.
Exactly. And what's even more remarkable is that this wasn't just a one-time thing. This aha moment was a turning point. It led to continuous improvements in the model's reasoning abilities.
So the AI basically taught itself how to learn more effectively. That's pretty amazing. It almost seems like it's mimicking human learning. Now, I remember hitting a wall when I was first learning to code. I would just stare at lines of code feeling totally lost and confused. But then I found a mentor, and they helped me understand the underlying logic. It was like this whole new world just opened up.
It's that shift in understanding, that ability to connect the dots. That seems to be happening here, and the implications are huge.
Absolutely. It makes you wonder what's next. If AI can have these aha moments, what other breakthroughs are just waiting to be discovered?
That's the million-dollar question, Elias. This research has opened up so many possibilities, and we're just starting to scratch the surface.
Well, this is definitely a conversation that we'll be coming back to as the field develops. But for now, let's dive a little deeper into the specifics of DeepSeek R1-0's aha moment.
One of the most interesting things is how this aha moment actually shows up in the AI model. It's not like we can just look inside its digital brain and see a light bulb go off.
Right. So how do we actually know that this shift in learning is happening? What's going on technically?
It's all about how the resources are being used before the aha moment. DeepSeek R1-0 was basically spreading its computing power pretty evenly across all the problems it was trying to solve. But afterwards, something changed. It started putting more effort into the harder problems, the ones that it stumbled on at the beginning.
So instead of wasting time on things it already knew, it started to prioritize the areas where it had more to learn. Kind of like a student realizing they need to spend more time on their weaker subjects to get better overall grades.
That's a good way to think about it. The model wasn't completely ignoring the easier problems. It could still solve those pretty efficiently. But it was definitely putting a bigger chunk of its processing power towards the ones that needed more thought and a more nuanced approach.
It's almost like it developed a sense of what it needed to work on, like a form of metacognition.
That's an interesting idea, Elias. While we can't really say for sure if the AI is experiencing anything like human consciousness, it's clear that it's showing a kind of adaptive learning. It's adjusting its strategies based on its past experiences and the challenges it's facing.
And that ability to adapt is a sign of intelligence, wouldn't you say? Whether it's biological or artificial, being able to learn from experience and change your approach is super important.
Absolutely. And that leads us to another interesting point. The paper talks about some technical details about the training process, specifically cold start data and distilling the model.
Oh yeah, I noticed those terms too.
Yeah.
For our listeners who love the technical stuff, can you explain those a bit?
Sure. Cold start data basically refers to the first set of data that's used to train the model. It was purposely designed to be very general, not focused on any specific task. This let DeepSeek R1-0 develop a broad understanding of language and reasoning before being fine-tuned for specific applications.
So it's kind of like giving the AI a well-rounded education before sending it off to specialize in something specific.
Exactly. And model distillation is a technique for taking a big, complex model and squeezing it into a smaller, more efficient version without losing too much performance, like taking a huge textbook and turning it into a short study guide with just the most important information.
So you're essentially making the AI faster and more efficient without taking away its intelligence.
Precisely. This is important for making these models more useful in real-world applications where things need to be fast and efficient.
Now, going back to DeepSeek R1-0's aha moment, one thing that stands out to me is that the researchers weren't actually looking for this. It just kind of happened on its own during the learning process.
That's what's so cool about this discovery. It wasn't because of careful programming or adjusting settings. It just came about naturally from the way the model was built and the reinforcement learning algorithm.
Which makes you wonder what other unexpected things might be hiding in these systems. What other abilities might pop up as AI keeps evolving?
That's a thought that's both exciting and a little scary, to be honest. We're really going into uncharted territory here, and there's no way to know what we might find.
It's like exploring a huge unknown wilderness. We might find amazing views or run into unexpected dangers. But one thing's for sure, the journey itself is going to be super interesting.
Definitely. And as we go deeper into this unknown, we need to be both careful and curious. The possibilities with AI are huge, but we also have to be aware of the potential risks.
That's a discussion for another time, maybe.
Yeah.
But for now, I want to go back to something you said earlier, Olivia. You mentioned that while this aha moment is important, it's just one part of a bigger picture. What are some of the other parts we're still trying to figure out when it comes to AI and intelligence?
One of the biggest challenges is getting AI systems to truly generalize. Current models are great at learning specific tasks, but they often have trouble when they face new situations or problems that weren't in their training data.
So it's not just about teaching AI to be amazing at games or translating languages perfectly. It's about giving them a deeper understanding of the world, more flexible intelligence that can handle the unexpected.
Exactly. And that's a challenge that goes beyond just improving algorithms or giving them more computing power. It needs a fundamental understanding of how the human mind works, how we learn, how we reason, how we make sense of everything around us.
It's like we're looking in a mirror trying to understand ourselves by creating these artificial versions of our own minds.
And that, to me, is the most amazing and humbling part of AI research. It's not just about making machines that can do things for us. It's about expanding our own understanding of what it means to be intelligent, what it means to be human.
That's a great way to put it, Olivia. And on that note, I think we need to take a quick break, but don't go anywhere, listeners. We'll be right back to finish our deep dive into the aha moment in AI. Welcome back to HyperTalkPod, everyone. We've been talking about this fascinating idea of AI having these aha moments. You know, those sudden leaps in understanding that we used to think were totally unique to humans. It's a pretty mind-blowing concept, and it has huge implications for the future of AI.
It definitely does, Elias. And what I find really fascinating is how this discovery changes how we think about learning and intelligence. It kind of blurs the line between what we call human and machine.
You know, one thing that really struck me in the research, Olivia, was how this aha moment came out of nowhere. The researchers weren't even looking for it. It just popped up naturally during the reinforcement learning process.
That's right. It wasn't from some carefully written code or fine-tuning. It happened organically from the model's structure and how the learning algorithm worked. It's almost like finding a secret passage while exploring a huge, complicated maze.
Exactly. And that unexpectedness opens up so many questions. What other hidden abilities might we find as these systems keep evolving? What other surprises are hiding under the surface?
That's a question that keeps me thinking, Elias. This aha moment gives us a peek into what AI might be capable of. It makes me think we might be underestimating these systems, underestimating their ability to learn and adapt in ways we haven't even thought of.
It makes me think about my own aha moments. Those times when you suddenly understand something in a new way and it changes everything. I clearly remember the moment when I finally got recursion in programming. It was like a fog lifted, and I could suddenly see how elegant and powerful this technique was.
It's those moments of understanding that really push us forward, both in our personal lives and in science. It's all about making connections in a new way, seeing patterns where before there was just chaos.
And it's amazing that we're seeing something similar happening in these AI systems. It suggests that the line between human and artificial intelligence is becoming more and more blurry.
It's a pretty profound realization. And it comes with both enormous potential and potential challenges. As we keep developing more advanced AI systems, we need to be really careful. We need to make sure we understand what we're creating.
For sure. The ethical questions are huge and complex, and we need to handle them with both caution and wisdom. But for now, Olivia, as we wrap up this deep dive into AI's aha moments, do you have any final thoughts for our listeners?
I think the most important thing to remember is that we're just at the beginning of the AI story. We're always finding new things, pushing the limits of what we thought was possible. And as we go deeper into this uncharted territory, we need to be open to the unexpected. We need to embrace those aha moments that will definitely guide us along the way.
Well said, Olivia. A huge thanks for joining us today and sharing your expertise. This has been a really eye-opening conversation.
It was my pleasure, Elias.
And to our listeners, thank you for tuning in to HyperTalkPod. We hope this exploration of AI's aha moment has sparked your curiosity and has gotten you thinking about the amazing potential of these systems. If you enjoyed this episode, don't forget to subscribe and leave us a review. Until next time, keep exploring, keep questioning, and stay curious. Who knows, maybe you'll have your own aha moment today.